Hello everybody, how are you? Today we will solve a lot of questions about integration, about trigonometric function. Look at this example. We want to find integration about 10x plus tan power 3x dx. First, we can write tan x coefficient outside between two terms. We can write tan x outside here. Then the result will be 1 plus tan power 2x dx. We know 1 plus tan power 2x, it will be sec power 2x. We must know identity about this expression, okay? So you must write tan x multiplied by sec power 2x dx. What about this expression? We know tan x, the derivative about tan x will be sec power 2x. So we have the function and derivative about the function behind it. So we must cancel this function here. We can cancel this function and add 1 to this power divided new power. Then the result will be tan power 2x over 2 plus constant. It's okay about this example. Again, integration about 10x dot sec power 2x dx. We have two functions. One of them is derivative about the other. So we must cancel the derivative about function, cancel this function, because tan x derivative will be sec power 2x. We must cancel this derivative and we must add power to tan x and divide it by this power. So the result will be half tan power 2x plus constant, okay? Question number 2. Derivative about, we want to find the integration about cotan 2x dx equal space. Cotan, we know cotan was what? Was cosine over sine. We can write here cosine 2x over sine 2x dx. We know numerator cosine 2x and numerator sine 2x. And we know sine 2x equal to sine x cosine x. And the integration about what? About denominator will be cosine 2x. Look at here again, this denominator. What about derivative about sine 2x? It will be cosine 2x multiplied by 2. So we must write 2 outside and divided by 2. So the numerator will be what? Will be derivative about denominator. So we can write half outside here and we can write then absolute value to denominator sine 2x plus constant. Why? Because the numerator is derivative about denominator. If we have 2 cosine 2x over sine 2x, we must write then sine 2x because the numerator is what? Derivative about denominator. So this function will be len absolute value to denominator sine 2x because the numerator is the derivative about denominator. Okay, this example we can solve it. We know x power 2 multiplied by e power negative x power c dx. We can find the derivative about this power here. The derivative of this power will be negative 3x power 2. Okay, negative x power 3, the derivative of this power will be negative 3x power 2, but we must divide it by negative 3. So okay, we must multiply by negative 3 here and divide it by negative 3. Why? Because this term will be derivative about this power. So we have function and derivative about its power. So we must cancel the derivative. We must cancel this derivative and write the result negative 1 over 3 multiplied by this function e power negative x power 3 plus constant. Okay, this is the result about this function. It's very easy. Okay, again we multiply this example by negative 3 here and divided by negative 3. Why? Because we have term, this term is a derivative about the power here. We must find the derivative about power behind it. because the derivative about this function e power negative x power 3 equal negative 3x power 2 multiply e power negative x power 3. That's the derivative. Here we will cancel it. To find the integration about this function will be negative 1 over 3 dot e power negative x power 3 plus constant. Another example, look at here. We have the function inside integration. We have the integration here. Sec power 5x dot tan x dx. Look at this example. We know the integration about sec will be sec tan, so we can write sec power 5x will be sec power 4x multiply sec x dot tan x. Why we do this step? Because sec tan, it's what it was derivative about function sec x. Sec x derivative about sec x equal sec tan, equal what? Sec tan. So we must cancel this expression. Okay, we can cancel the derivative and 8 power 2 here and divided the new power. So the result will be sec power 5x over 5 plus constant. Then the result will be half 1 over 5 sec power 5x plus constant. It's okay or not? Again sec power 5x tan x, we can write sec power 4 multiply sec x, because sec x multiply sec power 4x equals sec power 5x. Why do this step? Because we know the integration about sec x equals sec x tan x. So we must cancel the integration here. What about this expression? I cancel derivative. We can cancel the derivative here and add 1 to 4 will be 5 and divided by 5. Since the result will be 1 over 5 sec power 5x plus constant. Can you solve this example? Tan power 3x dot sec x. We can let u equal sec x, okay, and du over dx equal derivative about this function. Sec x will be sec x tan x. Okay, in this example we can write what? We can write integration here. Tan power 3x, we can write it tan power 2x dot tan x, and we can write sec x equal u dot dx equal what? Dx equal du over sec x tan x. Okay, we can write, look at here, dx equal du over sec x tan x, sec x tan x, du over sec x tan x. We can cancel tan x with tan x and sec x with u, because u equals sin x, sec x, u equals sec x, so we cancel it. Then you can write the result here, tan power 2x du tan power x du, and we know relation about tan power x and sec power 2x. We know this expression, tan power x equal what? Identity, you know it, it will be sec power 2x minus 1. It's identity, du. It's okay. We must cancel sec x to u because u equals sec x, so we can write integration about u power 2 subtract 1 du, and we can find derivative or integration about this expression for du. We can add 1 to the power and divide it by this power. The result will be third u power 3 subtract u plus constant, and we can cancel u and write sec x, so the result will be third sec power 3x subtract sec x plus constant. This is the result about this question. Okay, we can solve about this integration. We know x power 4, the integration about this will be 4x power 3, but it was x. We can't find or convert the numerator to be derivative to denominator, so we must put x power 4 will be u, or x power 2 equal u to find the derivative about denominator. Look at here, we can write x over x power 2 all to power 2 plus 1 dx. I will let x power 2 equal u, and we can find derivative about this function. We can write 2x equal du over dx, then dx equal du over tx. And this example we can write here x over u power 2 plus 1 dot dx equal du over 2x. We can cancel x with x, then the result will be 1 over u power 2. We have 2 outside, we can write half outside here, 1 over u power 2 plus 1 du, and denominator 1 over u power 2 plus 1 du, which is the inverse of the denominator. We can write half 10 power negative 1, it's the inverse about this function, x power 2 plus 1, because x power 2 equal u, as is the inverse. Okay, this is the inverse about this function. We can write 10 power negative 1, x power 2 plus 1, or plus constant, why? Because y power 2 is the inverse about this function, x power 2 equal u, so u power 2 1 over y power 2 is the inverse of this function, 10 power negative 1, this function x power 2. Look at this example, integration about 2x dot sine 2 power x dx. We can write 2 power x equal u equal, let u equal 2 power x, and we can du derivative u for x equal 2 power x multiply by ln 2. Okay, and we can write dx equal du over ln 2 multiply 2 power x. So in this example we can write here 2 power x equal u dot sine u dot dx equal du over ln 2 multiply 2 power x equal u. We can cancel u equal u, and ln 2 is constant. We can write it outside here, 1 over ln 2 outside, integration sine u du. We know integration about sine will be negative cosine, so we have 1 over ln 2 dot negative cosine u plus constant. Okay, so the result will be negative 1 over ln 2 cosine u plus constant, and we can cancel u and write e power x. Then the result will be negative 1 over 2 power x ln 2 cosine 2 power x plus constant.